Hey everyone, welcome back to Project Streamliner. This is going to be more of a short technical update video. Since the last video, I wanted to keep testing stability control and variations of different upgrades on the version 1 body. But I had a fatal accident with a head-on collision with a curb that essentially destroyed the version 1. So I decided there's no sense in reprinting out version 1 and that I needed to go ahead and just move to version 2 and incorporate some of the lessons learned. So that's what I wanted to kind of review with all of you, just go through the design itself and show some of the improvements and learning from version 1 that I've tried to incorporate into version 2. Okay, so first up, some notable differences from version 1. I've gone ahead and widened the car. The narrow track width just wasn't going to work. I was at 60 millimeters before, and I've taken it up to about 80 millimeters now. That seems to, at least in the version 1 body, greatly enhance the stability. Another lesson I learned from version 1 was that the weight distribution is everything for this style of car. So I've changed several pieces of the design to allow me to get a better weight distribution of the car. The first thing is I don't have a front shock right now. I might go with a tuned mass damper later, but I have this 1000 milliamp 6S battery right here, which will be going directly against this front bulkhead, and this is the heaviest component in the entire car at 130 grams. So this drastically shifts the weight forward and brings it much lower in the chassis. Before I had the battery way back here in the middle and it was sitting up quite high in the chassis. I also changed the design of the battery door, which allowed me to place the ESC, the second heaviest component in the car at 80 grams, directly on the floor in the middle of the chassis. This puts the weight well below the roll center. In the version 1, I actually had the ESC standing up vertically almost in the place of where this battery was, which was definitely raising the roll center and actually putting too much weight on one side of the chassis versus the other, which caused it to roll to the right easier than it would roll over to the left. I've also moved the mount for the shock absorber, which in version 1 was down here on the floor, up to the roof. I found that the shock absorbers were much lighter than I had initially anticipated. So this allows me to eventually put a servo right here directly on the floor, which may actuate a parachute or some sort of active aerodynamics in the rear, as well as keep the electronics, the ESP32 and all those other components much lower in the chassis. In version 1, I actually had them, the ESP32 was on top of the shock absorber, which was well above the roll center and too far back in the chassis, which again added to the instability of the chassis. So after moving all this weight forward, I also discovered something interesting when I reran the CFD. The center of gravity moved from about here, the midpoint, to almost right here, just behind where the front bulkhead is and where the 6S battery is, which is great. That's excellent for stability of a high-speed RC car. But what this also meant was that I no longer needed this large, rather draggy rear wing on the car. And this is because the center of pressure falls to right about here on the middle of the chassis. And this is well behind the center of gravity. I think I was at like 25% FOE kind of setup. So I was able to remove the rear wing, which only moved the center of pressure about 5 millimeters forward, which was great. It also took out this large surface area that was above the roll center of the vehicle, because I was very concerned about any kind of crosswinds essentially causing the vehicle to roll over because they would be hitting this sail that was so high up in the air. So what's interesting about all these changes is because I was able to eliminate the rear wing, the net change in drag is actually fairly small at only about a 10% increase over version 1. But the overall frontal area actually increased by 20%. So I think that's a very good thing. It also is due to the fact that I was able to get a slower taper towards the rear because I'm widest up here at the front, right by the front tires. And then I'm able to narrow the entire length of the chassis all the way back to the motor in one straight line back to the tail, which allows the air just to, follow along very nicely. And I'm actually really not having any side vortices anymore. I was also able to get the nose to be a much better elliptical shape. And this allowed, again, the air to flow nicer around the chassis itself, as well as because it's so nice and rounded, again, it helped to keep that center of pressure moved further back. So as I talked about in the last video, I was facing a lot of challenges around the braking configuration. The rear wheel doing all the braking and accelerating is definitely a trick, particularly braking, which is rather abrupt based on how this ESC works, and it's destabilizing the entire chassis. So because the accelerometer itself is directly in line with the rear wheel, I don't need, like a typical car would have, wheel speed sensors. I can actually use the accelerometer data directly to sense whether or not the rear wheel is locking up. So what I've done is I've gone ahead and created a rudimentary ABS and traction control algorithm using the accelerometer data, which is actually quite easy and works quite well. It does require a little bit of tuning based on the actual surface that you're running on, but once it's tuned, you can essentially go full brake and the car stays in a straight line, which is awesome. Okay, so the last thing I wanted to cover was this little strange object up here in the front. This is actually the GPS module and its antenna. As I mentioned in the last video, I wasn't sure whether or not I was getting a clean GPS signal, and that's actually been an issue for me. And part of that's because I'm running on concrete, which is reflecting the GPS signals back up, the radio signals, and causing a lot of interference. So what I've done is I've actually gone ahead and added a ground plane, which is a little circular aluminum plate here that the antenna goes on top of. And what this does is it helps to deflect some of those reflected radio signals that are coming up from the concrete itself. And it's actually vastly increased the accuracy of my cheap little GPS module. I am going to go to a better GPS so that I can get more reliable readings and do some other cool stuff, but I think for my purposes this is plus or minus a half a mile an hour, so more than accurate enough. And having this GPS module up front also helps to keep it away from any interference from the ESC and the electric motor itself way back here. As I mentioned a little bit there, that that one rear tire is doing all of the work for this entire car. So the thing I'm working on right now is how to actually incorporate some form of active aerodynamics to both aid with braking as well as increase downforce for faster acceleration. That's what I'm continuing to work on now. And hopefully in the next couple of weeks I can start actually printing out some prototypes and getting this thing assembled so that I can get version 2 up and running and get it out there, and hopefully we'll hit triple-digit speeds. That's my real goal for version 2, is if I can get to triple-digit speeds, I'll be really happy. Thanks for watching, and stay safe out there.